Greetings from the Hermitage, and welcome to the third video in our series on addition and subtraction equations. In this video, we'll present a visual representation of what the numbers are doing in those addition and subtraction equations. We'll be looking at the math involved. For teachers who like to use manipulatives, we've provided some suggestions on this page. You can always come back and look at that later if you like. Since we're using vectors, it's likely a good idea to have some idea what those are. For us, a vector is simply an arrow drawn between two numbers on a number line, and that arrow can point either left or right. The length of the vector is the distance between the 2 points on the number line. We'll talk more about that in detail a little bit later. But other people in math and science use vectors in very sophisticated ways, far beyond what we'll be doing here. Weathermen and pilots, for instance, use vectors to visualize wind direction and speed. Engineers use vectors to visualize and calculate loads on bridge I-beams and cables. And the vectors are so well understood by these engineers that they often program their computers to do the actual calculations. And a little closer to home and a bit more timely, epidemiologists use a form of vectors to visualize and predict the spread of diseases. But for us at this time, we'll use vectors to not only visualize math, but to invent some math along the way. In its simplest form, a vector or an arrow represents a distance on a number line, and that arrow can point either left or right. We can represent the distance between the tail and the head of the vector, that is the distance between the 2 points on the number line, as an arrow with a number in it, as you see at the top of the page. On the other hand, we can represent a vector as a number with an arrow above it that points either left, like you see at the bottom of the page, and that's called vector notation. With those preliminaries out of the way, it's time to play the vector game. And as with any game, there are some rules that we have to know. Let's see what the rules are for this game. The first rule is that vectors that point to the right represent positive numbers, and vectors that point to the left represent negative numbers. To add vectors, just like we do with numbers, we'll attach the tail of the second vector to the head of the first vector. Here's an example of what that looks like. I'll take this first vector and put him on the number line. Notice that I butt him up against the 0. We always start at 0. And I'll take the second vector, bring him down to the number line, and since we're adding, we'll just put the blunt end of that arrow against the pointy end of the first arrow. You can even add negative vectors to a positive vector. Here's an example of that, and we do it exactly the same way. You always place the blunt end of the second vector to the sharp end of the first. So I'll grab this positive vector here, put them right there by the 0 point on the number line. But this time looks a little bit different. To do this one, okay, the blunt end of the red vector lines up with the arrowhead because we can't just line it up the other way like we did the first time. This calculation right here, number-wise, looks like this. That's going to be 3 plus a -7, I'll put that in parentheses, equals some number. We'll save that for a little bit later, what the numbers actually are whenever we have a formal number line. And probably the most important rule is that subtraction is defined as adding the opposite. I'll say it again. Subtraction is defined as adding the opposite, and it looks like this. So we're going to subtract this red vector from this green vector. We'll start by placing the original vector on the number line. Now we have to worry about the fact that we're subtracting, so we need to get the opposite of this guy right here. So this is subtracting a negative vector. We do just the opposite. Instead of subtracting the red vector, we're going to add the green vector. In this case, we just bring this guy down here, butt them up to each other like that, and we're well on our way. Let's go ahead and do that again with numbers. Recall that subtraction means add the opposite. So we want to subtract this -4 vector from the +3 vector. I'll go ahead and grab that +3 vector and put them on here. Recall that subtraction means add the opposite. I have the opposite of that -4 vector here represented as a +4 green vector, and we'll just add them right here just like we always had. And we can see that that answer is 7. The head of the second vector adds up to 7. So here's what it looks like with numbers. We had 3 subtract a -4 equals something. This subtraction right here says add the opposite. So we'll change that subtraction to an addition. And this is going to be a +4. We're adding the opposite. And we all know that 3 + 4 equals 7. Just as a reminder, down here at the bottom of the page, subtraction means to add the opposite. Let's finish off the rules. There's only a couple of more. As you can see from what we've been doing, the first vector will start at 0 on the number line. And the number inside the vector, like these two vectors here, tells you the magnitude or the length of the vector. Let's do some for real now, from start to finish. So we're given these two vectors. -4, we're going to add -3, and it doesn't make any difference in this case which vector we put on the line first. Addition can be done in either order. And just to show you that's the case, I'm going to go ahead and put this -4 vector on here. And then we're going to add this guy, and to add him we just butt the blunt end of that one up to the pointy end, the arrowhead of the first vector. and it comes out to be -7. Let's go ahead and do it in a different order. I'll move this guy out of the way, move him out of the way. Remember, addition can be done in any order. So in this case, we're going to start with -3, bring this guy down, and add him to that. And if I be a little bit more accurate with what I'm doing, we'd see that it still comes up to -7. Let's look at what that looks like with numbers. So we had a -3 vector and adding a -4 vector, and we can see that it came up to a -7 vector. Getting rid of the vector notation, it's -3 plus -4 equals -7, and most oftentimes you'll see this addition written as a subtraction like this. I prefer it to do it like this. Gives me more of a visual of what's going on. We have -3 subtract 4 equals -7. Now here's an example of vector addition with both a positive and a negative vector. I'm going to do it two different ways to show you it doesn't make any. Remember, we're doing addition, and addition, the order of addition doesn't make any difference at all. So we'll start this case with a -3 vector, and then we're going to add the +7 vector. We just line them up about like this. And if I can get everything lined up, we see that comes out to about 4, as it should. Now let's do it the other way. I'll put the 7 vector first. And then we'll add the -3 vector to it. And if we kind of bring him down like this, we line him up, we can see that the result is 4 after that addition. Remember that for addition, it doesn't make any difference what order that we do the addition. Let's do another one with vector subtraction. In this example, we'll subtract the 7 vector, this long one here, from the 3 vector. I'll just go ahead and put the 3 vector down. Remember that whenever you subtract, it means adding the opposite. So we just convert this positive green vector into a -7 vector, and now we're going to add that to the vector that's already there, kind of line them up like this, and we see that our answer is 4. That's about right here. With numbers, it looks like this. We had the 3 vector subtract a +7 vector. Remember, this subtraction here means that we have to change the order. So now we have a +3 vector add a -7 vector. Taking it out of vector notation and just with numbers, this becomes 3 plus a -7. We can abandon that plus sign. I prefer not to, but you'll typically see it written as 3 subtract 7, and that's going to be -4, just like shown here on the number line. And finally, one more subtraction example. I've written it with vectors and in vector notation. So we're given this -3 vector, and we want to subtract a -7 vector. The first thing we have to be mindful of is that subtraction means to add the opposite. So instead of subtract here, it's going to be add over here. And the opposite of a -7 vector is a +7 vector. So I'll just take this -3 vector, slide them onto the number line like this, and then we're going to add the +7 vector. Like this, and if we bring them down, we can see that our answer is going to be +4. Now with numbers, it looks like this. We had a -3 vector subtract a -7 vector equals a -3. We change the subtraction to an addition and change the negative into a positive. Write it with just numbers. It's going to be -3 plus 7. And this answer has to be the same as what we saw with the vector addition. Okay, so we're almost finished with that. Now remember, you can go back at any time you like, rewind the video. You can stop the video at any time to get a clearer understanding of what it is. I know it's a lot of material that we had. But now for those of you at home or at your desk, this is pretty complicated with all these colors and numbers and everything. That took a lot of work putting that together. But let's say that you're at home. What you're going to need is a ruler. So we'll get this guy here. Get them all lined up. And then we're going to draw a line. We're going to construct a number line. I'll leave the ruler there for a second. Grab a different color, and we'll put some tick marks in at these different places every so often. It's important that if you're going to be accurate with the vectors, that all these distances are the same. Maybe I could use a different color, huh? So we're putting the tick marks in. We'll go ahead and get rid of that ruler. Well, you can't really see the tick marks too well, but they're there. The important thing is that you have a 0 and then some tick marks placed equally apart. And then you can use that just like I did here. So let's say that we wanted to add this is my 0, and we're going to add a -3 vector and a 7 vector. We'll just come here, count over 3. There's your -3 vector. Now you're going to add 7. So you'd count from the head back this way. So it's going to be 1, 2, 3, 4, 5, 6, 7. And draw your next vector like that. So, and you can see it 1, 2, 3, 4. This equals 4. Well, ladies and gentlemen, thanks for your attention. All I've got now for you is that that's all, folks. Be safe. Con cuidado. Look forward to seeing you again soon.